Guys, and welcome back. Today I'm going to go over your Unit 4 study guide with you really quickly. It is my sincerest hope that you have at least gone through your study guide and tried to answer everything first. But this will help us along the way and help us make sure we have all the correct answers to study for our Unit 4 test that's coming up very, very soon. So, question one reviews the steps of the water cycle. So, you do have a word bank down here, and then you've got the letters that correspond to the different steps. So, we're just going to put these in order. So, let's start with A here. So, A is condensation. And remember, condensation is when the water vapor in the atmosphere condenses into clouds. So, here we've got the water vapor that's existing in the atmosphere being condensed into our clouds. B is then precipitation. So precipitation is just the liquid that falls to earth. This can be rain, it can be sleet, hail, snow, any kind of liquid that falls from the clouds to the earth. C is going to be your infiltration. So infiltration, it's not really a good depiction of it here, but infiltration is when the precipitation falls onto the ground and then it infiltrates into the ground. So infiltration slash percolation is when the water actually moves into the ground. This could also technically be runoff because we see that this water is moving into the river. So I decided to do infiltration here because infiltration is kind of what we focused on, especially when it comes to groundwater. But runoff would be an option as well. And then finally, when we see where the water goes from the ground to the atmosphere, this is evaporation. And then it is transpiration if the plants are doing it. So evaporation is when just the radiation from the sun causes the water to evaporate into the atmosphere. And then transpiration is what the plants do when they sweat um, out of their leaves. So question two says plants lose water in a process called, and that is going to be transpiration. So remember, transpiration for plants is kind of like sweating for humans. So they lose their water intentionally and they release it back into the atmosphere. So lesson two was the water table. So we are highlighting the correct answers here. So it says the amount of space between the pores of sediment in the ground is porosity or permeability. So here it's going to be porosity. So remember, porosity is just how much space is in between the sediments that are in the ground. So the more space between the sediments, the more porous it is, and the less space, the least porous. Now, porosity is also related to this idea of permeability. So, how well the water can run through the pores is going to be the permeability. So, the porosity is just the size of the pores, the size of the spaces, and then permeability is how well the water runs through. So, if we have a sediment that's very low porosity, it will also have a low permeability because there are less spaces for that water to run through. So high porosity typically translate to high permeability and vice versa. So here we have question five says clay, sand, or silt is the smallest sediment and therefore the least permeable. The answer there is going to be clay. So clay is the smallest, which means it is the lowest porosity and also the lowest permeability. So a lot of times landfills and also like if you were going to do like a koi pond in your backyard, you would want to line it in clay because the water is not able to seep through clay. All right, so 6 says in figure 6.2, what letter labels the zone of saturation? So if we take a look here, we've got different labels here, but here this line is going to be our water table, right? So our water table is just the upper bound of our zone of saturation where there is water that fills the pore spaces, and then up above we have no water in the pore spaces. So F would be our zone of aeration where there is no water, and then D, that is below this water table, is going to be where all of that fresh water is and where all of that groundwater is being stored. So the answer there is D. So D would be our zone of saturation. And remember, if it's saturated, it is full of water. So moving on, we had to just fill in this word bank. So this is just a review of eutrophication. So if we read this correctly, this is how this particular paragraph should read. So runoff from agricultural fertilizers can make its way into our freshwater systems. This leads to algae blooms, and as the algae dies, the bacteria in the water need oxygen to do their decomposing job. As the bacteria use the oxygen, the overall dissolved oxygen levels decrease, which can harm the organisms that live there. This is called eutrophication. So remember, fertilizers in agriculture do contain food for the plants that algae also really like. So when it rains and the fertilizers wash into the water system, the algae will bloom and eventually those algae will die and they will need to be decomposed. So there are bacteria in the water that are really good at that, but the catch is they have to have oxygen in order to do the decomposing. So what they will do is take the oxygen from the water, break down the algae, but as a result, the dissolved oxygen levels do decrease, and this can lead to death in certain organisms. And then this whole process again is called eutrophication. So question 13, talking about groundwater depletion, it says in coastal areas, the overpumping of wells can lead to the contamination of freshwater table with salt water. This is called saltwater intrusion, and we've talked about that a few times now, but basically if you live in a coastal area and you are overpumping your well, and you are just using the fresh water at, an obscenely large rate, what can happen is that salt water actually gets pulled into the freshwater table and can contaminate the well. Normally, the salt water doesn't get into the well because the fresh water is pushing against it. But if you are over pumping, you can it's almost like a sucking motion where you suck the salt water into the well, and that is not good. So 14 says a drop in the water table produced when water is overpumped from a well is called blank. And this is called the cone of depression. So remember that cone of depression forms when you overpump a water table and it can lead to a decrease in the water table as well. 15 says any formation in which groundwater rises on its own under pressure is what? And remember, this is an artesian well. So the answer for 15 is an artesian well. If you remember our aquifers, they flow underwater. An unconfined aquifer um, doesn't have a impermeable layer of rock above it, meaning that it's open to being recharged by precipitation. It's also more vulnerable to pollution, but on the other hand, it's not pressurized. So if we have a confined aquifer, which is caught between two layers of impermeable sediment, it naturally pressurizes so that you don't have to pull it up. So it naturally will pump up on its own when it comes from a confined aquifer, and that is called an artesian well. Moving on to our wastewater treatment, there were 3 steps of wastewater treatment that we need to know. The primary stage is when large items are caught by screens, and then the waste is allowed to settle out of the water in settling tanks. Your grit chamber is also in your primary stage, and that is where your coffee grounds and your eggshells are allowed to, or just like any small sediments that aren't dissolvable in water, they're able to settle out as well. In the secondary stage, oxygen is given to bacteria in the aeration tank so they can break down the waste in the water. And then in the tertiary or final stage, the water is treated with UV radiation and chlorine in order to disinfect any remaining wastewater. Now, that is a very general overview, but of course, the details are in that unit for lesson number 6 when we learned about wastewater treatment. So water quality, we're just matching the indicator of the water quality to the correct description. Remember, water quality is like a grade, so how you guys get a grade in this class. We also use different parameters to classify water quality. So the first one says a measure of how acidic the water is. It's best for waterways to be neutral between 6.5 and 8.5. And that answer there is B, pH. So pH is a measure of how acidic or how basic water is. This one says a measure of how hot or cold the water is. It's better to be lower, and that's going to be D, your temperature. The reason it's better for the temperatures of waterways to be cooler is because cooler water holds more dissolved oxygen, and dissolved oxygen is necessary for organisms to live. The next one says a measure of how much sediment is in the water. The lower, the better. So this is going to be A, which is turbidity. Remember, turbidity is just how much sediment is there, how cloudy the water is. The cloudier the water, that would be the indication there's more sediment. This can also lead to increased temperatures because remember, the sediment can heat up in the sun, and it can lead to lower dissolved oxygen levels as well. So we want our turbidity levels to be low. The next one says comes from agricultural fertilizers. Too much can lead to algal blooms and eutrophication, and that's going to be E, your nitrates. And nitrates are just like the food that are in the fertilizers for the plants and that the algae also love. The last one says organisms that live in the water need this to breathe. This value should be high in supporting waterways, and that's going to be C, dissolved oxygen. So remember that when we did that water quality assessment, when we looked at the different addresses in Charlotte, basically the well, our particular one was a partially supporting, but there are different levels that you can assign to waterways depending on their different criteria. So you've got your supporting waterways that have lots of organisms and would be generally healthy. You can have a partially supporting, an impaired, and then a degraded as well. 18 says to list 2 things that you can do to help reduce your water footprint. These will vary based on what you guys feel that are in the scope of what you can do. But some responses that would be appropriate would be reducing your time in the shower, switching to energy efficient appliances, collecting rainwater for at-home plant watering instead of getting it out of the tap, installing low flow toilets. Those are kind of like they don't use as much water to flush. And that is a question on your test. There's a question that asks, what can you do to help conserve water? And the answer is the low flow toilet. So if you're watching this and you hear that, then you should get that right. And also turning off the faucet when brushing your teeth. These are not the only examples, but they are a few that you guys could have chosen from. And finally, just to wrap it up, 19, which of the following is not an ecosystem service provided by wetlands? And that's going to be a source of water pollution. Remember when we talked about wetlands, there's 3 very important things they do. They filter water, they collect and control waste and flood water, and they also provide a habitat for a lot of different unique organisms as well. So it doesn't make sense for them to be the source of water pollution when they themselves filter out contaminants and pollutants. And just a reminder, wetlands are things like swamps, bogs, um, marshes that are covered by water most of the year, and they just serve as a very natural filtering area on coast of different states. We in North Carolina do have quite a few on our coast. And then finally, we learned about river basins. 20 says another word for a river basin is, and that's going to be watershed. So watersheds and river basins are the same thing. Do not get a watershed and a wetland confused. A watershed is all of the area, all of the land and the water in an area that drains into a larger river system and eventually the ocean. And then a wetland is an area that's covered by water most of the year. And it says true or false, river basins include all the land and water that flows into larger river systems. I just gave you that definition, so that answer is true. And then we live in the Catawba River Basin. So it says Catawba or Mississippi. We live in the Catawba River Basin. And remember, many of our watersheds slash river basins in North Carolina do flow to the Mississippi River, but we don't live in the Mississippi River Basin. And that's that. I feel like we did that in record time. If you guys have any questions, let me know. And if not, have fun studying for your test.